Hi students, in this video we're going to expand our list of polyatomic ions from the basic 16, the fundamental list of 16, to the 34 polyatomic ions that you need to know for this class. There are going to be important and industrially significant polyatomic ions that are not on the list of 34, but we just have to draw the line somewhere. So we already know the 16 polyatomic ions that I gave you. They are in the list, the appendix that I gave you. And here's the appendix A, the key polyatomic ions to know, and you have to memorize these 16 polyatomic ions. So there they are. I'm not going to review them because we've reviewed them before, but I will put them on the camera here so that they are in the video, so that they are documented in this video. So the first thing I want to point out again is something that I've told you before. These polyatomic ions, these fundamental 16, are arranged in columns, and the columns correspond to their charges. So one of the ways that this can help you memorize them is that you can color code these ions in your flashcards or when you're writing them, and the colors can then correspond to the charges. That's not to say that these substances actually have those colors, but it's just a way that you can color code the text when you're making your flashcards, so that, for example, the 2+ cation is red, the 1+ cation is orange, the 0 column is yellow, so there's nothing in the yellow column, the 1- charge column is green, the 2- is blue, and the 3- is violet or purple. And so that's the colors of the rainbow there, and maybe that will help you remember. Students have told me in the past that if they color code this text on their flashcards or put a colored dot on the flashcard that corresponds to the charge, then that does help them recall the charges. They may not remember, for example, they may remember sulfate's formula except for the charge, and they may not remember the charge, but they may remember that there was a blue dot on that card, and then they can say, that was a 2- charged ion. So there again, these are arranged in columns. These are 16 that you just have to memorize. And we've been working on these for a few weeks now. I've given you an assignment where you had to write these over and over again to show that you're studying them and so forth. So again, these are the basic 16, the fundamental 16 that you have to memorize. And I say memorize because there's no special pattern that is going to help you learn these other than the way I've arranged the charges. There's no special pattern that's going to let you remember that nitrate is an NO3 with a minus charge, for example. There are other patterns for the remaining 18 in our list of 34 that you have to know, but these 16 you basically just have to memorize, okay? So if we go back here to our list of the 34 that we have to know, it says, notice in the handout with the basic 16, the columns correspond to ionic charges. How can this help you memorize them? Possibly by color coding columns based on charges. So that's one possible way that may help you actually learn those charges. Because remember, the charge on the ion is part of its formula. So sometimes students ask me, do we have to know the charges too? Yes, because the charges are part of the formula. So a hydroxide is not just OH, it's OH with a minus charge. Okay, with that said, these 16, we're going to add to these 16. To these 16, we're going to add 3 more that follow this pattern right here. And so these next 3 you can learn by following a pattern if you know these basic 16. And these 3 new ones are going to be based on the ions, the nitrate, the sulfate, and the phosphate. So I've written them here in green. These are not the new ones that you have to learn. These are ions that you already should know. They are in the fundamental 16, but the new ones that we're going to learn are based on these, and they are related to these because they have one less oxygen than those original ions. So here it says, generally, ions ending in the ate have one more oxygen than ions ending in ite, as long as we're talking within a family. So what I mean by within a family, if we're talking about nitrate and nitrite, the nitrate will have one more oxygen than the nitrite. Okay? So what does nitrite look like? One less oxygen, and that's nitrite. Okay? So it's an ite ending, and it's related to the nitrate. One less oxygen. Charge is the same, right? This is sulfate, so sulfite would have one less oxygen, but the same charge, sulfite. And I would like for you to do the last one. This is phosphate, so I would like for you to write the formula and the name of the ion that has one less oxygen than that. Go ahead and pause the video and write that down. All right, coming back, if this is phosphate with 4 oxygens, then one less oxygen, but the same charge, PO3, 3 minus, and this is phosphite. So ite endings have one less than the ate anion, and we have to compare them within the family, between the ate and the ite of the same series of ions. So notice, the reason I'm specifying that is that notice that nitrite has 2 oxygens, but sulfite has 3 oxygens. So just because it has the same ending, ite, doesn't mean they have the same number of oxygens to each other. I have to compare them to the ion from which they were derived. Sulfate had 4 oxygens, so sulfite has 1 less. Nitrate had 3 oxygens, so nitrite has 1 less. So there we have just added 3 more ions, nitrite, sulfite, and phosphite. And the way that we can learn these is we learn the pattern of 1 less oxygen turns it from an ate ending to an ite ending. And so if you know the fundamental 16 and you know this pattern, you've just learned 3 more without having necessarily to memorize them. You have learned them. So there we go. We've added 3 more. 3 more ite ending anions that are derived from their ate anions, nitrate, sulfate, phosphate, nitrite, sulfite, phosphite. Okay, moving along, we're going to add 11 more. And I'll make a note here that we're adding 11 more. I am going to write 12 ions in this space, but one of them is one that you already learned up here. So the one that you learned up here in the list, the basic list of 16, is the chlorate. And I'm going to make a table here with 3 columns and 4 rows. Okay. And notice it says, notice the pattern for remembering the oxyanions. An oxyanion is an anion that has oxygen in it. So all of these that I've mentioned up here are oxyanions, right? Chlorate is an oxyanion because it has oxygen in it. Oxyanions of chlorine, bromine, and iodine. So we're going to have chlorine and bromine and iodine, and then under each one we have 4 rows. And so there are 3 columns and 4 rows under these headings. So here again, if we have already learned chlorate, CHLORATE, and the formula is ClO3 with a minus charge. That is a lowercase l, not a capital I. So if this is chlorate, then we have bromine and iodine oxyanions that follow that same pattern. So if we replace chlorine with bromine, it's going to be bromate. B-R-O-M-A-T-E. And if we replace the chlorine with iodine, IO3 with a minus charge, that is iodate. So I want you to notice something. By learning chlorate, ClO3 with a minus charge, and learning this pattern, we can start to learn other ions without having had to memorize them. We could just learn the pattern so that we could extend the one that we did know into a pattern. Well, you notice that I left a row empty up here and 2 rows empty down here. We're going to fill those in as well. So there is a pattern within a series of oxyanions of chlorine. And so that depends on how many oxygens you have. You can have one more oxygen than chlorate, ClO4 with a minus charge, and you'll notice that all of these ions will have the same charge. They'll have the -1 charge. So this one is chlorate. That's the one we know from way back that we learned early in the semester. And one more oxygen is called perchlorate. All one word, but it has the prefix PER, which means beyond. So it's one oxygen beyond chlorate is the perchlorate ion. So the name for the ion, all one word, is perchlorate. So we have chlorate and perchlorate. Well, if there's a pattern that can be followed for bromine and iodine for chlorate, there's a similar pattern that can be followed for perchlorate. So I would like for you to take a moment, pause the video, and fill in these top 1, 2 boxes. So I'm looking for the oxyanions of bromine and iodine that are analogous to perchlorate. So go ahead and fill those in now, pause the video, and resume when you're done. All right, returning to these, we're going to fill in the 2 oxyanions of bromine and iodine that are analogs of perchlorate. So we're going to switch out the chlorine and put in bromine instead, BrO4 with a minus charge. And now it's not perchlorate, it's going to be perbromate. PERBROMATE. And if we do the same thing over here, it's not going to be perchlorate or perbromate, but it's going to be periodate. So IO4, capital O, right, with a minus charge, periodate. PERIODATE. Now it may look like it's pronounced periodate. It's spelled that way, but it's pronounced periodate, because it's one oxygen beyond iodate. Okay, we can continue this pattern in this first column and have one oxygen less than chlorate. And you have already learned how we're going to deal with this, because we know that if we have one oxygen less in an oxyanion, one oxygen less than the ate anion takes what ending? It's ite. So what are we going to call this one with one oxygen less than chlorate? If you said chlorite, you got it right. So chlorite, CHLORITE, chlorite. So take a moment, pause the video, and fill in the remaining 2 in this row. All right, so if you fill in the rest of this row, we switch out chlorine and add bromine, so it's no longer a chlorite, it's a bromite. One oxygen less than the bromate is a bromite. One oxygen less than the iodate is an iodite. Okay, we're going to finish this first column by adding one more ion here, And it's going to be following the same pattern, ClO4, ClO3, ClO2, and now we've just got one oxygen. And if you have one oxygen less than the ite-anion, then there is a special prefix that we use called hypo, H-Y-P-O, H-Y-P-O. Hypo is the prefix that means below or beneath. And you can think of terms such as hypothermia, when your temperature drops too low, or a hypobaric chamber, which is a low pressure chamber, or a hypodermic needle, which is a needle that goes hypo, below the dermis, the skin. So hypo, one oxygen below the chlorite, is below the chlorite. It's hypochlorite. So notice that the prefix hypo always goes with the ite ending, right? You don't have hypochlorate, and you don't have perchlorite. The per, it means beyond the chlorate, so perchlorate. Hypochlorite means one below the chlorite. So pause the video for a moment and finish up the rest of this row. All right, continuing on and finishing up the rest of this row, we've got one oxygen below the bromite is hypobromite. And remember, this is all one word, and this is the new name of the ion, right? That is the hypobromite ion. And over here, if we just have one oxygen over here, this is below the iodite, so it is hypoiodite. And there we go. We have 12 oxyanions of chlorine, bromine, and iodine. And now we have covered the pattern, which will allow you to learn them without having to have to memorize them all. So again, I make the distinction between having to memorize something and having to know it. The original list of 16 you have to memorize because there are no tricks or patterns to be able to learn those, other than maybe color coding their charges. But the remainder that we've been covering below that, you can learn them without having to memorize them because you're learning the patterns that allow you to determine them or derive them as you need them. So here again, we have 3 columns of 4 rows. So there are 12 in this chart, 12 oxyanions of chlorine, bromine, and iodine. Why have I only said 11 new ones here? Because you already knew the chlorate. So the chlorate is one that you had already learned in your basic list of 16. And this is also the key to learning all the rest. If you know chlorate and you know the patterns for going above and below and side to side, then you learn all of these without having to memorize them all. So ClO3 is the key. O3 is the key. 3 is the key. That's the chlorate that you already have learned. 3 is the key. If you remember that the chlorate is the ClO3 with a minus charge, and you know the pattern, then you can build all of the rest of them. Moving on, we're going to add 4 more. So we're going to add 4 more in this section down here. And these 4 more are the special hydrogen-containing polyatomic ions. So hydrogen-containing polyatomic ions. Because these ions are hydrogen-containing, they are easily mistaken for acids, which have hydrogens in their formulas. So we have to be very careful about these. These hydrogen-containing polyatomic ions are derived from ions that we have already learned up here in the list of basic 16. Remember these basic 16. And the ones that we are going to use to derive these are carbonate, sulfate, SO4 with a 2- charge, and phosphate. So I'm going to write those down first in green. They are not the new ones that we are learning, but they are the ones that we're going to derive the new ones from. So CO3 with a 2 minus charge, that's carbonate. And then we have SO4 with a 2 minus charge, that's sulfate. And then we have PO4 with a 3 minus charge, and that's phosphate. So again, these are not the new ones. These are the ones that are already on the list of 16 that we already know. However, we are now going to expand our list by 4 more to have hydrogen-containing polyatomic ions. So basically what's going to happen is we are going to add a hydrogen to each of these formulas, and the hydrogen is going to come along as an H+, and when that hydrogen is added to this formula, it will add a positive charge to the charge here on the ion, and therefore that -2 in this case will drop down to just a -1. So if we do that, we get this formula. HCO3 with a single minus charge, right? Because we added an H, it brought along a positive charge, which offset that 2 minus charge by 1, and so turned it into a -1 charge. HCO3 with a minus charge. Now there's an older term for this ion, and I'm going to write it down, but it's not the term that we're going to use. I'm going to write it down because you will have seen it probably many times in your life. This is called the bicarbonate. Bicarbonate. So sodium bicarbonate, for example. But the naming convention that I want you to use here is not bicarbonate. It is the modern convention of referring to this ion by saying hydrogen carbonate. Hydrogen carbonate. So it's 2 words. Sometimes you'll see this written all as 1 word, hydrogen carbonate, but more often you'll see it written as 2 words, and those 2 words are referring specifically to a single ion. So I'll give you an example of how you might see that. In a formula where you have a sodium, which we know is a +1 charge, and a hydrogen carbonate ion, which is a -1 charge, you might see sodium hydrogen carbonate. This is what we used to call sodium bicarbonate, and what many people still do, okay? Sodium hydrogen carbonate. And by seeing that hydrogen in the first position, that is what throws some students for a loop, because they see that hydrogen and they think, oh, I know that acids have hydrogen in their first positions, but this is not an acid. This is just a hydrogen-containing anion, a polyatomic anion. And it's called the hydrogen carbonate anion. Okay? We're going to do the same thing for sulfate. So sulfate, if I add a hydrogen here, it becomes HSO4 with a single minus charge, right? And what are we going to call it? It used to be a sulfate. Now it has a hydrogen in it, so it's a hydrogen sulfate. Okay, this is the hydrogen sulfate ion. This is the hydrogen carbonate ion. Now you notice that when I start with a polyatomic ion that has a 2 minus charge, if I add a single hydrogen to that, then it reduces the negative charge to only a -1. If I were to add another hydrogen, that other hydrogen would offset that charge completely, and this would no longer be a charged particle. So I cannot add another hydrogen to these ions and still have them be charged. So carbonate and sulfate can only have one hydrogen-containing derivative. When we look at phosphate, however, phosphate has a 3- charge on it, which means I could add one hydrogen to create a 2- charged ion, or I could add another hydrogen to create a 1- charged ion. That's exactly what we're going to do right here. If I add a single hydrogen to this and it brings a positive charge, then I get an HPO4, and this 3- becomes a 2-. I could add another hydrogen, which will bring another positive charge, and it will bring that 2- to a 1-. So those are two hydrogen-containing derivatives of phosphate, where I've added one hydrogen, and it goes from a 3- to a 2-, and I've added another hydrogen, where it goes from a 2- to a 1-. And this is where it potentially gets very confusing for students, because seeing this H2 in the beginning looks an awful lot like some of the acids that we encounter. H2SO4, for example, sulfuric acid, starts with that H2. But if they are charged particles, or if they are appearing in ionic compounds, we'll know that these are polyatomic ions, hydrogen-containing polyatomic ions, based on phosphate. So, what do you think that we're going to call this one? If we add one hydrogen to phosphate, it becomes a hydrogen phosphate, right? I haven't left myself a whole lot of room. Hydrogen phosphate, PHOSPHATE. This is a hydrogen phosphate ion right up here. In order to distinguish this ion from this ion, I tell my reader or my listener how many hydrogens I've added. I've added 2 down here, so it is the dihydrogen phosphate. Okay, so I have when I add a single hydrogen, it becomes a hydrogen phosphate. When I add a second hydrogen, it becomes a dihydrogen phosphate. These are 2 words that refer to a single ion. Dihydrogen phosphate is just the ion, and I could have that ion paired up with any number of cations. I could have sodium dihydrogen phosphate, ammonium dihydrogen phosphate, calcium dihydrogen phosphate, and so forth. This is just the ion name. Okay? So we can see we have 4 new hydrogen-containing ions. The hydrogen carbonate, the hydrogen sulfate, the hydrogen phosphate, and the dihydrogen phosphate ions. So that's 4 more. So if we add up these numbers in red for all of the ions that we have to know for this class, 16 plus 3 is 19, plus 11 is 30, plus 4 is 34. And that gives you your 34 total ions. Okay, 34 total ions that you have to know for this class. Now I understand, I will tell you this right away, I know that this is a lot to learn. You may have thought learning the basic 16 was a lot to learn, and now I've just given you 18 more to learn. But these other 18, you can learn by knowing patterns and applying patterns, right? So as long as you know the patterns, they will allow you to derive the ions as you need them. But you need to know all 34.